All right. We got a plot twist here. There's only going to be three parts, not four parts, because I forgot that the third and fourth part actually are intimately connected. And also, I'm going to try and get this one done a lot quicker because I have to go pick up my son from daycare, so I don't have too much time. So, this one's about evolutionary psychology. Evolutionary psychology was huge in psychology as a field towards the end of the 20th century. There are a lot of misconceptions about evolution. I'm not going to get into all of them. Suffice it to say, evolution is not a process where you become bigger and stronger over time. In fact, sometimes seemingly the opposite can happen. Most biologists believe that dinosaurs. It's really inaccurate to say this, but in a sense, dinosaurs died off, but they kind of evolved into modern birds. That's not if you squint, that's a halfway decent way of describing it. Yeah, so it's not survival of the fittest; it's survival of whoever reproduces in the current environment. If the current environment can't support T Rexes, but it can support chickens, then the T Rexes that are more like chickens are gonna be able to reproduce, and the T Rexes that are more like T Rexes are not gonna be able to reproduce. So this guy Buss here is one of the big founding fathers of contemporary evolutionary psychology. When Darwin released his idea of evolution, from the get-go, there was a lot of people drawing inferences about what implications evolution has for psychology, human psychology, and Darwin himself wrote about why our emotions evolved, what purpose they must have had at some point. So, evolutionary psychology was not new by any means, but it kind of received a new impetus in this time. And this guy Buss was a big part of that. But yeah, evolution is not an engineer. It's not designing something from the top down. It is actually a very sloppy, clumsy process where uh, just whichever organisms happen to die less and reproduce more will carry their genes forward, and eventually you'll get different species out of that. What we don't want to do when we're weaving evolutionary elements into our theorizing is to commit the adaptionist fallacy. Adaptionism is an erroneous argument where you say, well, there's some behavior that an organism engages in, or there's some physiological component that an organism has. That behavior or component, therefore, must serve an evolutionary purpose. In reality, we have a lot of what are called spandrels. We have behaviors that are a side effect of a previous adaptation, or we have physiological features that are a mere side effect. For instance, what we now see as feathers on birds have evolved over time to be more conducive to flight, but very, very evolutionarily older versions of feathers on organisms that looked little, if anything, like birds looked very different, although the same genetic materials are present. It's believed that the earlier feathers, which looked more like cotton, kind of a very cottony kind of appearance, was more for regulating body temperature, not meant for flight at all. It wasn't until organisms could try accidentally gliding or something like that and found use for gliding that you started getting the ball rolling on the whole feather thing. Similarly, with human behavior, there are many things we can do that don't necessarily serve an evolutionary purpose in and of itself, but we have the ability to do it because of some other purpose. For instance, we have language and art and music and culture that might be because we evolved a very large cerebral cortex because we needed one in order to survive, because we had to plan and coordinate hunts and hunter-gatherer times. Uh, that doesn't mean, well, when you have a big cerebral cortex, you can have abstract thoughts as a side effect, and abstract thoughts. You start thinking about life. You write music and poetry and invent things like culture. It's not like those things are a direct consequence of biological adaptation. It's kind of and possibly an indirect result of that. Darwin's original views were that the organisms that were the fittest are the ones that end up reproducing and their genes gets passed on. Neo-Darwinism says, well, actually, it's not the survival of the fittest. It's not the individual organism that needs to survive. It's really if your behavior is going to support genes that are similar enough to yours, not exact, they don't have to be exactly yours, then that is good enough. That will you will see behaviors in organisms that are conducive to preserving the lives of next of kin, let's say. So you'll see animals and organisms like ants do things that look suicidal. It's definitely not going to encourage the passing on of that organism's specific genetic code, but it does help support the genes in general of similar organisms. So it's more like it's not the specific organism that's being subjected to evolutionary pressure, but it's the genes that are within a certain distributional similarity to each other. So it's not personal fitness, it's inclusive fitness that modern evolutionary theory considers to be subject to selection pressures. You also, if you go deep into evolutionary psychology, you'll hear them talk about something called the era of evolutionary adaptiveness or environment of evolutionary adaptiveness, which kind of refers to what I was talking about earlier at hunter-gatherer times. Modern Homo sapiens sapiens, and yes, that is what we're called, Homo sapiens sapiens, there's two sapiens, are actually more advanced than previous hominid species, and previous hominid species, from what we can tell, still had pretty impressive abstract thinking skills and stuff. So you have to go very, very far back in the not just human evolutionary timeline, but just the hominid timeline. And by the way, there are hominid species that came about, lived, I think, about 700,000 years and then became extinct, like Homo erectus was alive. That species was around longer than Homo sapiens sapiens were ever around. We haven't even caught up. Kind of crazy to think about that we're not even the longest lasting hominids. But what is the case for evolutionary psychology? Evolutionary psychologists say that we have certain mental structures or our emotions or our mate preferences, different behavioral patterns, our psyche in general. We have these things because they served an evolutionary purpose, or they are a spandrel of some other evolutionary adaptation. So what is the evidence for this view? Well, one is that we have certain innate predispositions. Infants cry when there's a loud noise. Other organisms appear to have innate reactions to, or pre-wired to biologically relevant stimuli. There's some organisms that seem to just already know to stay away from snakes and spiders. They never have to learn what snakes and spiders are. They just already know to stay away. Human infants seem to already have some understanding of what a face is. They react differently to face-like stimuli compared to stimuli that have the same visual elements of a face but aren't arranged in the right way. There are also phobias, and this is a great quote. Their preparedness of human learning is most clearly manifested in the case of phobias. They typically emerge full-blown after only a single negative reinforcement, and terribly difficult to extinguish. It is a remarkable fact that the phenomena that evoke these reactions consistently, such as closed spaces, heights, thunderstorms, running water, snakes, and spiders, include some of the greatest dangers present in mankind's ancient environment, while Guns, knives, automobiles, electrical sockets, and other far more dangerous perils of technology, advanced societies are rarely effective. It is reasonable to conclude that phobias are extreme cases of irrational fear reactions that gave an extra margin needed to ensure survival. Makes sense. Maybe we have a special fear module in our brain that has evolved to really overreact and just really err on the side of caution. We need to develop phobias because it's safer overall to develop phobias than to not be scared enough of something. I find this hard to believe because people do develop phobias of things like elevators and airplanes, which didn't exist in prehistoric times, but I'm just going to leave it at that. One of the biggest hotbeds of evolutionary psychology theorizing has to do with mate selection. Here's a great quote for you. An attractive mate will have characteristics that may be unrelated to physical attractiveness as portrayed by popular media. These more important characteristics might include value as a nurturer and provider, reproductive fitness, and worthiness as a partner and parent. An attractive mate will have characteristics that tell us that our mate will help to ensure our survival as well as produce and enhance the survival of our children. So, Buss and Friends did a large multicultural, multi-country survey of mate preferences, and this is an important tactic because one of the biggest null hypotheses of evolutionary psychology is how do you know this isn't just a learned behavior, right? If it's evolved, then it should be transcultural. It's all humans have this, or virtually all humans have this. So that's why it's so important that they did a multicultural study, because people from diverse cultures have very diverse learning histories. And yet, Buss and Friends found that overall, males and females value things in each other that are conducive to nurturing offspring. Males are more interested in females overall, on average, on youth and good looks. These are things that are associated with being fertile. Females also value these things. However, they're willing, on average, females are more willing to trade off. They like good looks, but if you have high earning capacity, lots of resources, and you're very ambitious and have high status, these are things that females, on average, are willing to they'll give you a pass on other things if you have this stuff. But we have to ask, is this learned? Is this necessarily innate? Because that's what evolutionary psychologists are saying, is that this stuff is innate. It's in our genes. I keep stressing on average. If you look at these two distributions of, I don't know what data this is, but like the red distribution is lower on average than the blue one, but they overlap a lot. If you picked someone at random from the blue distribution, it would be kind of indistinguishable if they came from the blue one or the red one. Same with the red one. It's just, on average, there's just this slight difference in where they peak. And that's what I'm talking about with the on average. Men, on average, are taller than women, but as everyone watching this knows, there are plenty of tall women who are taller than men. You can go find plenty of men that are shorter than a given woman. These are averages. Something else evolutionary psychology, or EvPsych, looks into is differences in cognitive abilities. So on average, men tend to be better at spatial navigation and better at multitasking compared to women. On average. It's just on average. I'm not being sexist. Wait, no. Sorry, I screwed that up. Men are better at spatial navigation and focused attention compared to women, on average. Women are better at multitasking, on average, compared to men. The evolutionary psychologist says, well, this is because the man's role was to go and hunt for food. You need to be able to navigate and find wild game, hence the enhanced spatial navigation. You need to be able to focus on the hunt better focused attention. Men aren't good at multitasking because they need to use all their mental resources on focusing on the hunt. Women are better at multitasking because women usually stayed behind and took care of, all the household stuff and the kids, babies running around. They're a big handful. I'm not saying this. The evolutionary psychologists are saying this. Don't get mad at me. And this is all just on average. You do see, on average, there are these differences in cognitive abilities. On average, there's a lot of overlap. So this does fit with what they're saying, but it is just on average. I don't know if I've stressed that enough. It's just on average. Well, this brings us full circle back to the biases and heuristics, prospect theory, all that. In the not late 90s, early 90s, some evolutionary psychologists said, hey, our judgment and decision-making patterns are probably themselves the result of evolution. So, in the era of evolutionary adaptiveness or environment of an evolutionary adaptiveness, our biases and heuristics probably made a whole lot of sense. That stuff that our gut is telling us, the mental shortcuts, probably were evolved and worked really well, or else we would have died and not reproduced. This is what people like Gerd Gigerenzer over in Germany are big fans of. They call themselves ecological rationalists. Humans evolved specific modules or cognitive algorithms or heuristics that are suited to the era of evolutionary adaptedness. And it's not humans that are irrational, it is the environment that is not fitting the environment that our brains were evolved to operate in. Modern society does not match the environment our brain is ready for. So we're not to blame, it's the environment that is to blame. That's the ecological rationality view. It's a melding of judgment and decision making, but instead of Kahneman and Tversky's original saying, humans have these systematically irrational way of doing things, so we need to learn what those irrational things are they do specifically, what are the details, and how can we ameliorate that or fix it, mitigate it. Gigerenzer says, no, these so-called irrational things are actually super rational. It's just that the environment is, we evolved for a different environment. So made sense back in hunter-gatherer times, and we just need to change the environment. One way, this is kind of not exactly a perfect fit, but one example of this is overeating and obesity. Not so much overeating, but the macronutrients. We arguably eat way more salt, fat, and sugar than we should. That's because in our contemporary environment, salt, fat, and sugar are highly abundant. They are packed into everything that's conveniently available to us. And we are wired to really love this stuff and eat it up. Because in the era or environment of evolutionary adaptiveness, if you found something that was high in sugar or salt or fat, it really behooved you to consume it and gorge yourself on it because it was a very rare commodity and you need those calories. Calories are scarce. So someone like Gerd Gigerenzer would say, it's not that we're irrational, it's that we're kind of programmed genetically, evolutionarily, to do certain things that used to be perfectly rational. It's that we need to change the environment, not our thinking, because, I don't know, am I drawing too many conclusions from them by saying it's not our fault, we can't be blamed, it's the environment? I don't know. If you can't tell, I'm not terribly sympathetic to this viewpoint. I can see some truth in it, but I think the general thrust of what they're saying is a bit wrong-headed. But this isn't Marx Opinions 101, it's the history of psychology, so I'll just keep my mouth shut and keep going. Gigerenzer and friends said it's not biases and heuristics, it's adaptive thinking. Fast and frugal heuristics. The brain has limitations in computational power, information processing abilities, limited knowledge, and our brains are actually highly efficient, they say, at coming up with solutions that are pretty good at delivering not an optimal judgment or decision or problem solution, but delivers something that is very good considering our limitations. So we're going back to Herb Simon. I think I noted that. Yeah, going back to Herb Simon again. It's not very original. I just can't keep my opinions to myself. They're unoriginal and they're wrong. Whatever. Yeah, so one thing they'll point out is a simple rule like how familiar or how recognizable does something sound can actually be a very legitimate cue or predictor of something. So, like one study that these ecological rationalists have done is they'll say, I want you to predict who will win in an upcoming soccer match. And people who know nothing about soccer will base their decisions on how familiar the country sounds. Argentina sounds pretty familiar. Brazil sounds familiar. Germany sounds familiar, but Luxembourg does not. You could probably name, Americans and Europeans are not. We have plenty of countries we've never heard of. Jakarta, I've heard of Jakarta, but I've heard of Luxembourg. But that's only because I have to think of names of countries that most people don't have very much familiarity of. Turns out that we use a little mental shortcut and we will predict winners of soccer games based on how familiar sounding the name of the country is. And these ecological rationalists will say, this might seem irrational, but if you don't know any better, we're actually very good at finding something that's a good enough cue. And it turns out that the more recognizable or more familiar sounding the country's name is, that actually is a predictor. It's not a perfect predictor, but it is better than random guessing to just go off of that if you're predicting winners. And that's kind of the general thrust of these ecological rationalists. We're not irrational, we're rational. Our brain is good at finding these little subtle cues that we can work with because we do have conscious access to this information of how familiar does a country sound. And that's how we make our judgments and our decisions. We make the most of our limited information. So let's go back to this example from the beginning of part 1. Let's say you have a breathalyzer test. It has a 100% chance of saying that you are drunk if you are indeed drunk. However, that if you are not drunk, 5% of the time it will tell you you're drunk even though you're sober. If you draw an American at random at 5 o'clock in the afternoon, there is a 0.1% chance that they will be drunk. So most people are sober at 5 p.m., let's just say for the sake of this thought experiment. So very low initial probability that someone is drunk if they're picked at random. Now, let's say I grab someone completely at random. That means there's a 0.1% chance that they are actually drunk. But the breathalyzer says they're drunk. So what is the probability that they are actually drunk given that they were picked at random and the breathalyzer test says they're drunk? Our intuition will often tell us, well, the breathalyzer said you're drunk, so I'm not going to go work out the math and calculate the percentages, but I feel like the breathalyzer has a 100% chance of saying you're drunk when you're indeed drunk, and it only has false positives 5% of the time, so it seems like you're probably really drunk. Well, turns out that gut feeling is wrong. If you took 1,000 people and took 0.1%, that would be one person, and the breathalyzer would very reliably say that one person is drunk. The other 999 people, 5% of the time are going to have false positives. That would be 50 false positives. You scale this up, you're always going to have more false positives than actual correct judgments, because while it is 100%, if you're indeed drunk, I do correctly say you're drunk 100% of the time, a very small false positive rate can really overshadow that. So when you're dealing with numbers and statistics and mathematics, these are all very evolutionarily new things that our brain is not actually evolved to really deal with. So these ecological rationalists say, well, look, if you reformat this problem to something that's more akin to what we're used to dealing with in our evolutionary past, we can deal with this more effectively. In fact, when you break it down like this, you're getting closer. But to really get into something that our brain is used to processing, let's say you have something like an inspector where you have a conveyor belt going by and you have, okay, here's a sober person, breathalyzer says they are sober. Here's a sober person, breathalyzer says they're sober. Here's a sober person, they have a false positive. So the breathalyzer says they're drunk, but they're actually sober. You just show them case by case the information, and this is more like what a hunter-gatherer would have to deal with. You go foraging, you go hunting, you learn certain cues, you learn the reliability when the weather looks like this, or when I see a pattern that looks like this. You learn the probabilities and the conditional probabilities on an intuitive level very well, because that's a format. Experience shows that we learn probabilities and stuff and on an intuitive level when we learn them on a case-by-case basis. And people in this research area say, that's why doctors will screw up if you give them, like, here's a medical test and it's got this many false positive rate and this is the population incidence. Doctors will misinterpret tests. But if you ask a doctor, like, hey, if someone comes into your clinic and they have these symptoms, what does your gut tell you? Since doctors experience these symptoms all the time, the argument goes, their gut will be very well trained because this natural clinical case-by-case experience has taught them well and taught their intuition. And our intuition is built around this type of it. You have to experience things, not by numbers and math, but by experience. At least that's how their argument goes. We have to change the environment to match what our brain is able to handle. It has to be closer to something a caveman can understand in order for us to make better decisions. If you can't tell, I think this is complete bull crap, but I'm gonna keep moving on. It's not complete bull crap. There's some kernel of truth to that, but I don't have time to get into it. So, are we rational or is the environment irrational? I think we are irrational, including myself. I think there are aspects of our environment that don't help, like the abundance of salt, butter, and fat available around. Open a drawer, open a refrigerator, go to a vending machine, it's everywhere. That doesn't help. Obviously, dealing with numbers and statistics is hard. It's easier, you might think, to just check your gut on something you've experienced on a case-by-case basis. I don't think this has much to do with evolution. I think it has to do with other things, but it's something worth thinking about. This question is called the Great Rationality Debate. Capital G, Great Rationality Debate. It has been raging since the 90s. There are people, mostly in Europe, mostly in Germany, but there are people in America too, some in Australia, that are big into this idea that no, humans are not irrational, you're just not measuring their capabilities correctly. The majority of people still stick with the old Kahneman and Tversky way of looking at things, where yes, humans are irrational, let's study how irrational they are and get the specifics and try to change it. Big debate still kind of going on. Well, I'm going to try and wrap this up real quick. So what are the criticisms of evolutionary psychology? Well, for one, it's what I call fan fiction. You speculate that some current behavior used to serve some purpose in our evolutionary past, but unless you have a time machine, you have no way of verifying that. It's speculation, unless you can go and do some genetic studies or go and do like some comparative cognition work. Evolutionary psychologists never do that. They like to just speculate and then move on. I'm not okay with that methodology, but if it's okay if you are. Another thing is it's very hard to rule out learning. So even with the mate selection stuff, men prefer youth and good looks. Women prefer that too, but they're more willing to trade off on things like that. Is that innate though? Maybe women learn these preferences by modeling what other women do in their life growing up. You want culture, even if it's a wide variety of cultures, maybe it's just a widespread cultural practice where women You see other women valuing men with resources. I mean, it's really hard not to say like it's just a practical necessity for some cultures. And then in other cultures, it might have been learned. It's hard to establish that something is innate. And then finally, adaptionism. We talked about this briefly in the beginning. Just because we are doing some behavior doesn't mean that behavior serves a purpose. That might just be the result of some other thing. We developed a large neocortex, which allows us to have abstract thoughts. Does that mean that we're evolved to create electronic music or rap? Does rap or electronic music serve an evolutionary purpose? Probably not. It's just probably this fun thing that we are able to do just as a result of having abstract thought. So, another thing is, how do you explain things like suicide? Doesn't seem very, suicide is very prevalent in the world and doesn't seem like it's good for passing along your genes. Birth control, the anti-natalist movement. I actually have met a few people that are anti-natalist. These are people who I don't understand. I haven't looked into this, but apparently they are like, they don't care if you have kids, but they're not going to have kids, and they're proud of that fact, and they're like excited by the fact that population growth is decreasing, birth rates are decreasing, and they're cool with this. I can't give you a more rigorous definition than that because I've never looked them up, but I will say the anti-natalist movement doesn't seem very evolutionarily adaptive, and evolutionary psychologists have no problem picking things that go with their theory. So if you're going to pick things that go with your theory, you have to also explain things that don't go with your theory. And I'll leave it to your imagination what kind of sex acts actually don't result in pregnancy but are nonetheless very popular. So yeah, can you beat the alternative hypothesis? Can you come up with a research finding that is a better explanation of the results than just kind of the default? This is how I look at things. Humans evolved the ability to have language and abstract thoughts. All of our diverse opinions and behaviors are not evolved or genetic. They're the result instead of us thinking and reacting to our experiences. We evolved the capacity to think and react to our experiences. That's the evolved part. All this other stuff is just what we've done with that thinking and reacting. Our genetics give us the hardware or format that we think with. Our experiences and thoughts are like the software that runs on that hardware. So I think the evolutionary psychologists are making a mistake by saying the software is evolved when I think it's just the hardware that's evolved. That's just my opinion, though. Of course, I'm going to inject it in here. I'm biased. That's the end of part 3. I went through it real quick because I have to go pick up my son from daycare now. You have a great day.